Hi everyone, welcome to Build 2025. Today we'll be talking about optimizing Llama on Snowflake. I'm Anika, our AI/ML partner engineer here for Snowflake, and today we have Anusha Dudi, Meta AI partner engineer. Thanks for joining us, Anusha. Today we'll be covering essentially how to optimize LLM models on our Snowflake platform today. Llama models, including Llama 3, Llama 4, integrate across various features on the Snowflake platform through Snowflake Cortex AI, which is a fully managed AI/ML service that runs directly in our Snowflake Data Cloud. The core of this integration is the ability to use Llama as an underlying LLM for generative and analytical tasks through both Snowflake Cortex LLM functions and Snowpark. So what are AI SQL functions? Snowflake Cortex is essentially a suite of SQL and Python functions, which we refer to as AI SQL, that allow users to invoke Llama models directly on their data stored in Snowflake. So some of these supported models are Llama 3 and Llama 4, and they're pre-integrated and require no complex infrastructure or data movement. They're also wrapped in a security perimeter, so you don't have to worry about data compliance, enmeshed with data observability and data lineage tools built into our platform today. Some examples of AI SQL functions include AI Complete, which is essentially a way of generating text completions, responses, or executing general generative AI tasks based on a prompt. So essentially, this would include complex instructions, synthetic data generation, and conversational applications. We have functions like AI Classify, which categorize text into a user-defined category. So Llama models can be used to perform the classification logic directly on your data. We also have functions like AI Summarize, which generate a summary of input text. And they fit really neatly into this section on the slide called AI Development Toolkit. So we see on the left-hand side, Cortex AI/ML functions, Llama models sit perfectly in the stack right there, of which you can still leverage all of the application features from Snowflake Notebooks to Studio to external IDEs like VS Code and applications and Snowpark container services, while still leveraging inbuilt MLOps features within the platform, all powered by container runtime and/or GPU optimized warehouses. So in our demo today, we'll reference how to use some of these functions to automate customer support analytics. Some of the advanced features of Llama models that are integrated into this end-to-end ecosystem include Cortex fine-tuning. So users can fine-tune supported Llama models on their proprietary Snowflake data directly within Cortex AI to increase accuracy and performance on specific enterprise tasks. We also have Cortex Guard, which acts as a safety filter. This filters out potentially unsafe or harmful LLM outputs and ensures that the layer of safety for applications is built on top of Llama and other models. We also have retrieval augmented generation models, so RAG models. And Llama models are used as a generator component in the RAG systems built on Snowflake. And this is in combination with Cortex Search, which is Snowflake's managed vector database solution. Llama generates contextually rich responses by synthesizing information retrieved from your proprietary data and documents. In addition to that, we have Snowpark container services, where Cortex LLM functions provide fully managed access. Snowpark container services allow advanced users to host and deploy custom Llama models. So this could include different versions or fine-tuned variants in a secure, isolated container environment directly on Snowflake for maximum flexibility and control. The next most important piece on Llama models that exist today on our platform is multimodality. So newer Llama models like Llama 4, Maverick Scout, and have multi-model capabilities, which integrate text and vision and are supported through Cortex AI SQL functions for image and document analysis tasks. So now we'll talk about why Llama models are important in our market today. Why are open source models effective? So Llama models on Snowflake Cortex actually offer a distinct advantage for enterprises, particularly because of high performance requirements, cost efficiency requirements, and general security solutions. These capabilities are ideally designed for organizations moving from initial proprietary model exploration to production scale AI, where both performance and operational costs become more than critical. By running open source Llama models directly within Snowflake, organizations can drastically reduce AI infrastructure costs and operational costs. And this is particularly valuable as AI usage scales. Llama models provide superior price to performance ratio compared to many proprietary alternatives, making it a high quality, sustainable choice for large scale deployments. So Llama as it stands today is tried and true foundation for enterprise applications, supported by a massive and active developer community, which the community continues to innovate, robustly support, and add a wealth of tools and resources to their open source kit. So by leveraging open source Llama models, organizations essentially have greater control. It provides full access to the models, which are crucial for fine-tuning and integrating strong domain-specific knowledge to achieve highest accuracy and relevance for business uses today. And today we'll talk about how you can use fine-tuning within the platform to accelerate accuracy. In addition to that, Snowflake's flexible and scalable data platform provides a perfect secure environment to harness these powerful and cost-effective open source models. So as your data grows, you can still expect performance to be stable. In addition, unlike other AI proprietary systems, Llama's open source designs means most organizations aren't locked into restrictive licenses or high costs. Instead, Snowflake will empower, as a Cortex model, you to tap into cutting-edge, community-driven AI technology that constantly evolves rapidly and transparently. So bringing these models to your data is very convenient and allows for dynamicism. In general, what we see here is a key distinction of Llama models on Snowflake boils down to both Snowflake's data strategy and the platform infrastructure on massive LLM inferencing and the fine-tuning system optimization stack that Snowflake maintains today alongside open source Llama. So essentially, these innovations let developers run massive models like Llama 3.1 405B with up to 3 times lower latency and up to 1.4 times higher throughput on just a single GPU node. So what this means is big-time AI performance and accuracy are achieved while simultaneously delivering massive cost savings. So Llama's 3.1 usage costs are typically up to 3 times lower per output token compared to proprietary models like GPT-4, which provides unparalleled performance without massive hardware hassle, cost, or vendor lock-in. So in essence, we see limitless flexibility. We can summarize the reason for using open source models on Snowflake Cortex. It's efficient, it's easy, it's trusted. With that, I'll hand off the next section to Anusha to discuss model selection criteria and evaluations on where we should use what models.
Thanks, Anika. Hey, everyone. As Anika mentioned, open source models like Llama enable efficient solutions at a much lower cost than proprietary alternatives. The flexibility for customization, deployment, and data security makes them ideal for enterprises and developers scaling AI solutions. The Llama family offers a range of models from lightweight edge options like 1B and 3B parameter models, smaller ones like 8B, medium-sized 70B model, and larger models like 405B and Llama 4 models. The latest Llama 4 models, Scout and Maverick, are multimodal, handles both text and images natively. They also have expanded context windows. Llama models have repeatedly been shown to match or outperform larger proprietary models in specialized enterprise tasks. For example, the Llama 3.18b model is highly adaptable and, when fine tuned, can match or outperform much larger models, delivering strong performance and low latency for real time applications, all at a fraction of the cost than proprietary models. As developers and enterprises build AI solutions, a common question we come across is, which model should I choose? Typically, accuracy, cost, latency are the most important factors for enterprises and developers. You might start with a higher intelligence model to get everything working, but as you scale, cost and latency become critical. At this point, you may want to migrate to your target model that best fits your needs across all these criteria. The slide here compares the models in terms of intelligence, speed, and cost. Maverick offers an optimal balance of all three, while 3.18b, as you see, delivers the highest speed and lowest cost. Another consideration in model selection is reasoning versus non-reasoning models. Reasoning models tend to be more intelligent, but they also consume more tokens and are expensive. If your application is latency critical, non-reasoning models may be a better fit. Model intelligence may not always correlate to highest accuracy for your use case. It's important to select a model that meets your target cost, latency, and size factors, then optimize it to improve performance and accuracy for your use case that fit your product needs. So having custom eval metrics and benchmark for your use case is essential to measure how models perform on your specific tasks. We recommend that everyone building AI solutions design evals thoughtfully, considering product goals and outcomes, define metrics and measurement criteria that include both qualitative and quantitative aspects. Developers often mention not having dataset as a challenge to build evals. We suggest integrating observability and tracing tools early on to capture trajectories as you test your project during development or through alpha and beta testing. This will help you curate datasets for evals and fine tuning, and it will also help you to identify issues early on. As you address the issues and apply optimizations like fine tuning to improve performance, continually test these changes and run your evals to ensure your model and product are progressing in the right direction. With that, I'll hand it back to Anika. She will walk you through how to build a use case with Llama on Snowflake and then demonstrate how to apply performance optimization.
Thanks, Anusha, for that exceptional breakdown of model criteria for Llama models and how to use them on the Snowflake platform today. I'd love to talk about a couple common use cases that we see for Llama models in production today. And I would summarize them in the category of the voice of customer analytics automation. So the first use case that we see quite often is automating low quality data filtering. The challenge today is massive data sets are polluted with lots of noise. So that's spam, bot-generated content, and irrelevant entries. Manually cleaning this data is slow, it's expensive, and it's a significant drain on data science models and resources. In addition to that, low quality data leads to inaccurate reports and flawed AI training models. Llama's value proposition on the Snowflake platform here is number one, intelligent classification at scale. So Llama models are able to leverage excellent natural language classifiers. So on Snowflake, they can be deployed as AI SQL functions in the form of an AI filter function or an AI classify function to instantly analyze every row of incoming text data. And we will see that in our notebook demo in a quick bit. In addition to that, we see proactive data quality. So the model learns to identify patterns specific to spam, bots, or relevant language, which is unique to your industry. So this is really ideal for specialized support use cases. It then applies filters before the data is used on your analysis or for model training and ensures only high quality, trusted data that enters your pipeline. In addition to that, we have security and governance. Since the model runs inside your Snowflake environment using Snowflake Cortex AI, your data actually never leaves your secure governance boundary. So you get powerful content moderation while filtering and maintaining full compliance. Overall, the outcome here is faster time to insight and higher quality downstream analytics by automatically culling data garbage before it even impacts your workflow. Another really valuable use case that we see in production is instant voice to text, topic, and tone analysis. One of the challenges we see is call center audio and meeting recordings. They're valuable, but the data tends to be inaccessible. So turning hours of spoken interaction into actionable business insights is typically a multi-step complex process involving external tools, which introduces more latency and data transfer risk. So Llama, in this sense, really impacts end-to-end analysis in SQL. So by combining SQL's native capabilities with Llama models, you can execute a complete voice analysis workflow natively in the Data Cloud. And again, you can do this within a notebook environment and share cross-functionally in your organization. So voice-to-text transcription, for example, can use a specialized AI function called AI transcript. So this converts audio functions, which are securely stored in a Snowflake stage, into accurate text scripts. In addition to that, topic identification can be done with AI Classify and AI Complete, as referenced before. And sentiment can be leveraged with Cortex function AI sentiment that qualifies emotional tone, identifying frustration, satisfaction, and it also helps with identifying prioritization. So in the end, we get real-time business insights. The entire process is orchestrated securely within Snowflake, so sales leaders can immediately see aggregated transcripts to see which topics are driving the most positive sentiment, or support managers can drill down into calls and see what's causing the highest frustration and what do we need to further improve customer sentiment. The outcome here is turning previously dark data into immediate actionable insights, which leads to better quality assurance, improved training, happy customers, and faster market intelligence, all with no data movement or third-party data transfer risk. The last use case that I would love to explore, that we will be exploring in production today in our notebook, in our demo, is automated customer support ticket analysis. Customer support operations are typically drowning in unstructured data, which means thousands of tickets, chats, emails every day. Agents and managers spend way too much time manually reading, routing, and trying to identify urgent trends. This causes a rampant amount of escalations, customer frustrations, and delays in resolutions. So in our notebook today, what we'll be exploring is how instant multidimensional analysis from a single Llama model can execute a series of complex NLP tasks on every incoming ticket in milliseconds. We have classification to automatically tag the ticket with the correct product, department, or issue type. We have summarization to condense lengthy customer narratives into brief, digestible summaries for the agent. We have entity extraction as well to pull out details like account numbers, error codes, impact features, logs. All of this helps us streamline operations. So what this enables directly is creating structured outputs that fuel more automation, like rapid routing of tickets. Tickets are immediately sent to the correct team with all the key information summarized. Urgent issues can be prioritized, and we're automatically flagging the most important ones in the highest priority queue. So ultimately, what we see is massively improved efficiency, faster issue resolution time for customers, and actionable insights into emerging product issues derived from both unstructured and structured data. Let's jump in and see how Cortex AI SQL in the form of Llama models can empower a support use case. Here we are. We can select our Cortex model allow list, which is our context of which Llama models we want to choose between. So Cortex will automatically select the most performant based off of your data needs and your quality output of response. In this first section here, we're using AI Complete function, leveraging Llama 4 Scout to summarize all the issues that we see in a screenshot attached to a support ticket. In this particular use case, for example, we see the issues shown in the screenshot that a user's bank has been declined for their transaction, preventing them from completing a ticket purchase for a Foo Fight concert. So this is dealing with image data. In this case, we can explore the reasons to use Llama 4 Scout versus Llama 4 Map. Both are multimodal compliant Llama models. In addition to that, we want to identify customer issues across text from the case and image data formats in this case. So we'll create an insights table. Here we can leverage more than one. So in this case, more than one Llama function. So we can see Llama 4 Maverick here versus Llama 4 Scout. This is depending on your context window. As Anusha discussed earlier, there's plenty of trade-offs. For example, Llama 4 Maverick pushes state-of-the-art multimodal reasoning and performance at a higher compute and cost, but with a sophisticated mixture of experts architecture, while Llama 4 Scout targets use cases that demands very long context windows, trading off multi-model breadth for that specialty. So you can choose in your case, depending on how sophisticated your support use cases, on which model makes most sense in the context of multimodality, context length, inference cost, and hardware availability. In addition to that, you can select a model like Llama 3.3 to complete and summarize some of the email exchanges that you see within your ticket. And some of the trade-offs here are model size and multimodality for cost and simplicity, suitable for smaller and cost-sensitive related applications. So here we can see summary of the insights in the ticket. Moving forward, one thing that would help unlock our automation workflow here is identifying which solution articles actually map to support tickets so we can figure out the right prioritization hierarchy for answering tickets. Using AI filtered from the models that we defined in our model context at the top, Cortex will automatically select the best model that matches solution center articles for each support ticket. And you can have a sense of how many of these tickets have solution articles and how can they be automatically dedicated to the downstream customer. In addition to that, we see top pain points by the month. We can analyze that using the AI ag function. Now, we see here we can generate top issues reported, and we can also see the percentage breakdown. We can prompt this each ticket by asking for a comprehensive list of all the issues mentioned. We can ask for how many of these tickets had additional outstanding issues, how many of these tickets had more than one issue, and then we can get an approximate frequency in percentage. Overall, what we see here is maybe we want to visualize these aggregated insights. We can see number of unique users, total number of tickets, as well as the top issues, which allows us to allocate resources more effectively and also allows us to route tickets more effectively. The next piece here in our automation workflow for ticket analysis is classifications. Taxonomy and specialized support case workflows is an outstanding challenge that we see in industry today that often involves a lot of customization. And one way we can do that is through simple English prompting. So we can define a prompt here. In this case, we're dealing with concert data. So we want to see how many of these tickets map to which music genre related to concert tickets. So here we can create a filter prompt that we're trying to see if the customer mentions any music genre preference in their comment. So here we see 4 different categories, and through a simple AI filter function, leveraging the filter prompt that we described, we'll get a subset of labels. We'll get our classified label. In this case, we have a couple labels. We have 4. We have electronic dance, indie, jazz, and rock. And we can see the distribution of those labels. In this case, we have a perfectly even class. So with that said, now let's take a look at how we can apply various performance techniques to enhance optimizations of Llama models on the Snowflake platform. So in general, before we start fine-tuning, customers may already be familiar with the basics of the LLMs and have a baseline for performance from evaluation of a base model with prompt engineering or a RAG. So while prompt engineering and RAG work are effective by injecting additional information into prompts, fine-tuned models actually operate efficiently with more concise prompts, thus lowering costs and reducing latency. So fine-tuning a smaller model with the right training data can potentially achieve performance comparable to larger models for customer-specific tasks, with leading to cost savings without compromising on quality. So fine-tuning in the context of specialized support cases is so impactful because it encodes your unique business jargon, product names, and internal resolution protocols directly into Llama model weights. And this allows the model to move beyond general language understanding to achieve higher accuracy and consistency in critical tasks like root cause classification, sentiment severity scoring, and generating actionable brand compliance summaries. So in a nutshell, here's how Snowflake Cortex fine-tuning looks. It's a serverless SQL Python function that you use for fine-tune, and it runs inference on LLMs. We receive specific outputs from unstructured tests, data in a cost-effective way, and it can be used through the fine-tuning API or the UI directly, just for training. And then you can set up tasks and streams to automating fine-tuning jobs. For inference, you can use SQL and Python functions in Snowsight or expose a custom app through Streamlit. In general, Cortex fine-tuning is a fully managed service in Snowflake. We have our data set here. You select the data training set and optional validation set for your own data to fine-tune a model. Cortex fine-tuning does automatic parameter efficient fine-tuning without manual parameters. And you can use fine-tuning models right after completion of training. No need to manage deployment or purchase provision throughput like other vendors. You only pay for training or inference tokens you consume. So you have instant deployment and prompting, and a serverless inference of fine-tuned models within a Cortex LLM function. Cortex models puts LLMs and AI models in the hands of every user. It's easy to use. Users can fine-tune and use industry-leading LLMs very easily with SQL or Python. It's secure, it's cost-effective, it's fully managed, so no data privacy concerns. It's serverless, so you don't need to manage it. Now let's see how fine-tuning is actually impactful for Llama models. We expect to see better and equal results with fine-tuning for one, and this is comparing Llama 3.1 with a larger context window of 4 or 5 billion params and 8 billion param. We also expect better or equal results at a lower cost, depending on the context window size. Lastly, we also see fine-tuning results, better or equal results for higher throughput for Meta 3B fine-tuned models. So as we saw in the Snowflake notebook earlier, you can plug and play with the Snowflake fine-tune model. You can plug and play with your own specialized fine-tune model in your notebook, and it can be immediately leveraged through your model context and then traced for experimentation using a native lineage features on the Snowflake platform. So here's an example of how you would do fine-tuning, and all of this code can be added directly as a SQL cell into your notebook. So you have your training table, your training data. You set your model name, you have your prompt, completion, output model names, epoch size, batch size, learning rate. And you can do this within direct SQL, or you can do this within a Python script using the Snowpark API. It is completely flexible depending on your application design. And here's an example of a prompt template that you could use in this context. So in this particular scenario of specialized customer support analytics automation, the chain of thought prompt template is actually extremely helpful, mostly because it improves model accuracy, transparency, and logical consistency when dealing with complex, multi-step analytical tasks. So customer support analytics, especially when dealing with unstructured data like call transcripts or chat logs, involves various reasoning tasks. So that could result in Llama model forcing the Llama model to show how it shows its work. What that could mean is complex task decomposition. Specialized analytics often require multiple steps. like extracting key entities, product names, error codes with custom jargon, customer sentiment from just plain raw text. There's also categorization. There's determining the root cause behind the context, and there's generating actionable insight, a summarized actionable insight on, like, for example, high volume negative sentiment related to the renewals process in the last 7 days. Now, in addition to that, it allows for step-by-step reasoning. So a chain of thought prompt template will allow Llama model to follow the sequence. So first it'll identify the problem, it'll classify the severity, then it'll determine the root cause. Fourth, it'll summarize the findings. This sequential process actually minimizes the chances of the model skipping a logical step or making a premature jump to a conclusion, which results in a zero-shot or direct answer prompting. So this avoids the common zero-shot errors that we see. In addition, we see reduced errors across the board. By breaking down the problem, as in any complex problem, the model can focus its attention on cognitive resources on each subtask, leading to a higher accuracy rate in identifying specific, nuanced issues that are critical for specialized support. So, for example, distinguishing between a refund request or an escalated policy violating refund request, which could save our business tons of money. In addition to that, we can enable transparency of the model and interpretability of the model. So we want explainability here. So this chain of thought prompting really allows us to have auditable logic. It explains the why behind an insight. So by having the Llama model output the complete chain of thought before the final analyst, the analytics team actually gets an audible trail of the model's decision. So you can see how the model went from a raw chat transcript to the final categorization and root cause. In addition, this allows for better debugging and refinement. So if the Llama model misclassifies the support ticket, the chain of thought output will automatically immediately reveal where the logic went wrong. So was it in the entity extraction step? Was it in categorizing the case? Was it in the final summarization of the case? So this will drastically speed up prompt engineering refinement. Another element is also building trust. So stakeholders are more likely to trust and act upon automated insights when the AI system provides a transparent, logical justification for its analysis rather than a black box answer. So we see a lot of benefits to using chain of thought prompting. Now let's understand how we can use few-shot training data as a fine-tuning approach. So this is exceptionally helpful for the same use case on Snowflake because it bridges the gap between Llama's model's general knowledge and your company's unique domain and data nuances with maximum efficiency. So fine-tuning a Llama model with few-shot training data is helpful because it helps you use unique data domain knowledge and data nuances. And the way it does that is you can bake in jargon and context within your data training set. So fine-tuning on a small, curated set of your actual support data teaches the Llama model in a specific world to recognize things like internal product names, feature names, company-specific error codes, tone and severity from high severity issues to low, and the model what might otherwise traditionally miss. In addition, you achieve superior consistency. So while prompt engineering with the few-shot examples can be good, fine-tuning actually permanently adjusts the model's weights. So this means the model's outputs will be far more consistent and reliable, especially on edge cases, compared to a prompt that has limited space for examples. In addition to that, we see some efficiency and cost reduction on the Snowflake platform once we use techniques like few-shot prompting. For example, a lot of the times this means that the way you prompt can impact the number of tokens processed. Shorter prompts, the main benefit here is it eliminates the need for lengthy token consuming few-shot examples in the prompt every time you run an analysis. So once the model is fine-tuned, a simple short prompt like analyze the sentiment and root cause for the following text is all that's required. Low inference costs are important as well. So fewer input tokens per request directly translates to lower compute costs and faster processing, so less latency within the Snowflake platform, making analytics automation pipelines more scalable and economically viable for high volume customer data, especially as your data needs grow. The other benefit here is high performance with limited data sets. So few shot fine-tuning techniques, actually like parameter efficient fine-tuning, are pretty powerful because they achieve specialization without requiring the millions of data points needed for full rim model training. So you can leverage foundational knowledge. So Llama has already learned general language structure or vast internet data. Fine-tuning only requires a few hundred to a few thousand high-quality labeled examples of your specific support interactions to specialize its existing knowledge for a task. In other words, doesn't require thousands of failed scenarios. You can fail fast. Faster deployment and iteration is also a huge consideration. Collecting and labeling a small and high quality data set is much faster than compiling a massive one. This allows you and your team to quickly adapt the model to new product launches, new support channels, or emerging customer issues with rapid training cycles, all still within a governed environment in Snowflake. So here's an example of how you would create a fine-tuning job and then point it at your training data table. Super simple, params don't change. We reference the fine-tuned database, we select the model of our choice, and we select the prompt. So overall, here's some best practices and techniques for performance. Number one, we want to maintain clean and well-structured training and validation data sets because it's essential to avoid issues like overfitting or catastrophic forgetting. So you want to limit epochs and batch sizes based on your data size and compute capacity to ensure efficient training. We also have synthetic data generation and model distillation within Snowflake Cortex AI, which can help create smaller, efficient models from fine-tuned larger models to reduce inference costs. And there's plenty of inbuilt functions that we have within Snowflake to do synthetic data generation. In our Llama cookbook that we will release after this session, you'll be able to see recipes for how you would do synthetic data generation. In addition to that, you want to make sure you design and ensure prompt and completion pairs are well aligned and cleanly structured in a Snowflake table with columns named prompt and completion. So this keeps the total tokens for prompt and completion well within the model context window limits. Next, you want to use structured outputs when you want the model to respond in a specific machine readable way. So starting with 100 high quality examples to balance fine-tuning time and effectiveness. Lastly, you can automate these fine-tuning workflows to achieve accuracy at a higher pace, at a faster pace, using Snowflake tasks and streams for continuous model improvement. And you can observe these experiments. You can observe them using integrations like weights and biases, or externally, open source tools, or you can use them in-house with our model lineage features. So in general, Snowflake's fine-tuning system optimization layer contains multiple reasons that speed up models. Number one, it's hardware agnostic with FP8 zero quant with 0.3 inspired parameter sharding. We have CPU offloading, which enables fine-tuning for hundreds of billions of parameters on a single node with reduced memory needs. In addition, we support very long context windows up to 128,000 tokens, which enables efficient memory and compute usage. Taking it one step further, we enable efficient single node inference on both legacy GPUs and concurrent hardware. Moreover, we have a Swift KV integration as an optimization into our fine-tuning system optimization. This is everything that lives under your fine-tuning function. And in essence, this enables reduction of inference costs by up to 75% by smarter data caching and faster AI inference data retrieval. Lastly, the Snowflake Cortex fine-tuning function leverages PEFT to fine-tune large models' efficiency without retraining the entire model, which reduces compute and memory demands. Now, should you have more use cases to optimize, you can leverage external libraries for optimizations using our Snowpark container services and Hugging Face integration, which we'll reference in our cookbook. So you can leverage LoRa adapters through VLLM. Alternatively, you can use Ray Core for distributing inference workloads through remote tasks and actors, which allows you to parallelize LLM inference calls and do batch processing or do complex transformations for your pipelines. For example, you can create Ray remote functions that are part of LLM inference asynchronously on distributed GPUs. All of those methods could be referenced within our GitHub link that we will reference in our QR code at the end of the presentation. I want to emphasize the SwiftKV optimization here. So SwiftKV significantly optimizes Llama inference because it focuses on the costly pre-fill stage, meaning the processing the input prompt. So there's a couple of reasons why SwiftKV is super important for Llama inferencing. It uses model rewiring, which is a single input KV, to allow tokens to skip about half of the transformer layers during prompt processing. So this effectively reduces compute by up to 50%. The next step is it uses KV cache merging to combine the cache of neighboring layers, which reduces the memory footprint up to 62.5% and enables a larger batch size for higher throughput. So these optimizations, combined with knowledge-preserving distillation, result in about a 2 times higher aggregate throughput and lower latency, with minimal degradation in model quality. So any fine-tuning function that you use with a Llama model leverages the SwiftKV. Lastly, let's talk about cost. So there are plenty of cost considerations when it comes to dealing with open source models on Snowflake Cortex and just in production grade use cases. The reason why open source models, Llama models, are effective are because they have significantly lower price per token compared to larger proprietary models, which directly impacts the primary cost of the driver. So that's the number of tokens processed. So here's a breakdown of why this leads to cost effectiveness. 1. The number of tokens is a core factor for LLM usage costs. So since Llama models on Cortex are often offered at a highly optimized competitive rate, a lower rate per million tokens immediately translates to a lower total bill for the same volume of work. So if your application processes 100 million tokens per month, a model costing $1.21 credits per million tokens will cost far less than a model costing, for instance, $3 than credits per million tokens. And this difference scales linearly with usage. The other dimension to model optimization and efficiency is related to high throughput and low latency. So Snowflake's optimization of Llama inference system stacks, which includes techniques like quantization, parallelism, and memory optimizations, means that we can process a higher volume of requests, which means tokens, faster and more efficiently on the infrastructure. And this efficiency gained is passed on to the user in the form of lower credit consumption for the model itself. Taking it a step further, we have right sizing. So the Llama family includes a wide range of models. So for example, the model selection criteria, you can delegate using a smaller Llama model for simpler tasks, which allows you to pay an even lower token rate while achieving the required accuracy. So in the case of the notebook, we saw you can specify the Llama 8 model. You can specify in that context that you only want to use models of a specific size. And so this practice actually maximizes cost efficiency. So the model's operation is distinct from the warehouse costs for query processing. So it's decoupled from billing. You pay for 2 things: the warehouse for running the SQL query that calls the Cortex function, and the tokens for the LLM processing. The Llama token cost is typically a separate fixed rate and not directly tied to the size of your virtual warehouse that you use in your SQL execution. The total cost equation is also important here. So by lowering the token price of the model like Llama, you can optimize the second and the most variable in the term of the equation, which would be independent of your existing data processing and infrastructure costs. In summary, the open source Llama models achieve cost effectiveness by providing significant performance improvements at a highly reduced token rate, which is the most significant component of an LLM usage charge. So if we talk about nuances in models like AI SQL, So functions like complete can be higher credit consumption depending on your overall context. So using complete with a higher intelligent model and skill prompting can actually parity almost all of the functions in this capability. And then you have summarize. If trust is important, you can use summarize or you can use complete depending on token volumes you can assess. Overall, cost considerations are in your control with full transparency. And we have an upcoming budgets feature coming to trace the efficacy of credits of Llama models on Cortex. So here's an example that requires a pre-configured Slack notification integration, of which can also be referenced on the GitHub with this code directly available. So in this case, we see logic for how we can configure the number of tokens and credits that we use across a specific period of time and set an alert to Slack once we exceed that threshold. Then we can create a task and set that task to any time interval to get an insight into how much we're spending at a given time. And if we don't want to exceed a certain threshold, we can limit that and stop that immediately. Lastly, I just want to highlight some of our upcoming cost features, our existing cost features and upcoming cost features on the topic of budgets. This will give financial teams a proactive governance tool to set spending caps on LLM services and alerting owners before they reached planned expenditures, for example. In addition to that, we have resource monitors. So this prevents unexpected cost overruns by automatically suspending or notifying users when LLM compute consumption exceeds predefined credit limits. We also have provision throughput, which allows users to secure a stable, low latency rate for a set credit price. So this guarantees predictable performance and cost, especially for high volume, real-time LLM inference. We have cost allocation tags as well, which are effective for attributing LLM token usage costs to the specific business unit or project responsible for consumption, which enables accurate internal chargebacks. We also have Cortex LLM function support. So this makes sure that LLM tokens based in credit usage can be tagged at the query level, making it easy to track and report on costs for analytical batch workloads. Finally, we have the exciting prompt caching upcoming as a feature, and this will overall reduce redundant token processing costs by storing the output of common prompts, preventing the LLMs from recalculating the same result multiple times. In addition to that, we have general batch calls through Cortex LLMs. So these are the batch calls are the AI completes, the AI classify over many rows of data. So in the case of the support tickets, analyzing 1 million tickets at once. This is highly efficient and due to underlying compute optimization for large-scale data processing. And the cost impact here is batching generally results in lower cost per process token and higher aggregate throughput because computational overhead is amortized across a massive volume of data. The tagging impact here is related to because the LLM call is a part of a single SQL query, the cost allocation tags applied to the queries associated with the warehouse or the database itself will automatically capture and attribute the entire token cost of that multi-million row analysis to the designated project. We also have API calls through the Cortex REST API. So the way this works is it allows API calls use dedicated REST endpoint for interactive low latency applications where one prompt is sent and one completion is immediately returned. So while the API is necessary for a fast user experience, it can be less cost efficient for bulk tasks than batching, as the overhead cost per request is significantly higher. The cost is still directly tied to the total number of tokens, prompt plus completion, that's used in real time for the interaction. In addition to maintain financial governance, the Cortex REST API also requires like Cortex allocation tags in the API request or the payload. So this will ensure real-time token-by-token usage generated by the external application so that it's accurately linked and allocated to the correct business unit, and in the Snowflake cost reporting tables. Overall, we're looking forward to releasing prompt caching and our budgets features. Please stay tuned through our Llama Cookbook. Here are some of the summary and takeaways that we had from our Llama optimization conversation on the Snowflake platform today. Please feel free to reference the GitHub link, this QR code, and thank you so much for attending the session today.